Hello everyone. So we are going to see how selection sort works. So we are going to apply selection sort logic on this array. Okay. So idea is very simple. What we have to do is we have to iterate through the array, find the index of the smallest element, okay, and swipe that element with the position we started. So let's say we are starting at position that is equal to 0, that is 3. Now we'll go from 3 to 7, 7 to 4, 4 to 6, 6 to 10, 10 to 2. Okay. Now uh, if we write the index as well, 0, 1, 2, 3, 4, 5, when we are iterating, we'll find out the index of the smallest element. That is nothing but 5. So 5 is the index of the smallest element over here. Now what we do is we swipe array of the position we started with array of the minimum index we got. So let's say mi is the minimum index. So we will swipe it. So here we have 5 as the minimum index. So 5 element at position 5 will be swiped with element at position 0. Okay, so how the array will look like now is 2 will be at first, then 7, then 4, then 6, 10, and here comes the 3, right? So one iteration done. Now on the second time what we do is we start from position 1. Earlier we started with position 0, right? This time we'll start with position 1, and from here we'll start iterating and find the minimum index again. So this time the minimum element is 3, and that is again at index 5, right? So we will again perform the same operation, that is nothing but a of 1 with a of 5. So now our array will look like 2, 7 will be side with 3. So 2, 3, 4, 6, 10, and 7 will be at last, right? Now on the next iteration, we keep our starting position as 2. Why we are moving our starting position? That is because 2 is at its correct position, 3 is at its correct position. So till here we have already sorted the array, right? That is why we are moving from next position. So now p is equal to 2. From here, if we start iterating, we'll get the minimum index as 2 itself, because 4 is the minimum over here. So if you swipe, you'll swipe a of 2 with a of 2, and nothing will change over here because 4 will get swiped with 4 only. So 2, 3, 4, 6, 10, 7, right? Next time our starting position will be 3. This time also 6 is the smallest, so we don't have to swipe anything. So we'll write a of 3 with a of 3. It will actually swipe, but nothing is going to change in the array, right? Next time we'll get 2, 3, 4, 6. Now our starting position becomes 4, where 10 is. This time if we iterate through the array, we will get 7 as the minimum. So index of 7 is 5. So this time we'll swipe a of 4 with a of 5, and we will get the array that is nothing but 2, 3, 4, 6, 7, 10. Yeah, so we stop our sorting when our position is at length minus 1 index. Okay, so here we start our swiping at second last element. Now let's see how many iterations we have done. We iterated for the first time, we got this array. Then we iterated for the second time, we got this array. Third time, this array. Fourth time, this. Fifth time, we got this. So see, when the size of the array is 6, basically we iterated 5 number of time to the array. Every time we got one minimum that we placed it at the point we started, right? So on the first time we started with p equal to 0, then p equal to 1, then 2, 3, 4, and at 4 we stopped. That is at second last element. And if you see now, you got a sorted array here, right? So 2 is the smallest element, then we get 3, then we get 4, then 6, then 7, then 10. So idea is very simple. We take the minimum element, swipe it with the position we started, right? So now let's see how we can code this. So I have taken an array of size 6, okay? I'm just looping in the array and printing all the elements. So let's see what will get printed if we don't do anything. So I'm just compiling it. Yeah, so we get the same array which we took here, 3, 7, 4, 6, 10, 2, right? Now we have to apply our logic to sort the array. So here we saw if we had 6 as the size, we iterated 5 times. That is nothing but 1 time less. So here also we are going to do the same thing. We'll write a loop for int I is equal to 0, I less than length minus 1, I plus plus, right? Now every time what we do is we will try to find the mean index and we'll swipe it with our position where we started. So starting position is nothing but 0. For the first time it was 0, next time 1, next time 2, next time 3, next time 4, right? So here basically here we can write minus 2 because length is 6, we are stopping at 4. Okay, now we want a mean index. So let's say mean index is I initially. Now we are going to loop int j is equal to, so we start looking at the minimum element from position. That position is nothing but I, so we can write here j is equal to I, j less than len, because we have to go all the way. And here inside this, if we find our current element, let's say array of j, if this is smaller than the element at mean index, then we will change our mean index to j. Yeah, that is very simple. And finally what we'll do, we will swipe our array with starting position will be I, and with array of mean index. That's all. So what we did, we took a mean index equal to I. Yeah, so we took mean index equal to I, and then we iterated from j is equal to I, j less than length, j plus plus, all the way towards till the end. We are seeing if my current element is less than the element at index mi, I'm changing my mean index. And finally, I'll swipe it. So now let's compile our code and run it. Yeah, we got the sorted array. One small optimization which we can do is, because we are starting at position 1 and already we have placed mean index at I, we can start from next element to compare. So here we can write I plus 1, and let's say the current element where we started, that is the only smallest element. So here you can keep this condition. If I is not equal to mi, then only swipe it, right? Because it doesn't make sense to swipe the same element with the same. So yeah, still we get the same answer, 2, 3, 4, 6, 10, 7. Okay, there is something missing here. 2, 3, 4, 6, 10, 7. So is it because of this? Yep. So we have to write len minus 1, but not len minus 2. We got the sorted array. Thank you.